overview picture of our senior design project is the element of portable device which is capable of providing the concentration of cortisol in a human sample. The device consists of a microfluidic system that drives the sample throughout the device, and then a potentiostat which is in charge of doing the electrochemical measurements to the device. Also, we have enabled the communication between the device and a server which provides the user all the information about their metabolism.
My contribution this summer consists of two tasks. The first one was to enable the wireless communication between the BeagleBone and the server, and the second one was to completely develop the web page as a responsive layout that allows the user to see the web page in mobile devices as an application.
Since our last report, I have worked on the development of the electrochemical setup where we do the measurements of the sensor, and then we are now at the point where we're comparing it to known values or from a known source to see the accuracy of the sensor.
Since our last report, I've been working on the sensing platform that's going to provide a pathway for the signal to go from the sensor to the cortisol sample and back to the sensor again. Also, I've been working on the development of the chamber, which is going to connect the sensor to the microfluidic system.
From the first progress report, I have worked on the configuration of the electronic hardware necessary to drive the microfluidic systems. I have tried to do an H-bridge with transistors, and then I passed to another option, which was using a chip that has two H-bridges embedded in it. And apparently that's the one that we're going to go with, since it's smaller in size and it consumes less power.
I developed a circuit for to control the microfluidic valves. This circuit now is needed to be, it was sent to print it. Now it's all just needed to be soldered. 3D parts for the plumbing of the microfluidic system were also printed, and that's ready to be implemented.
As it can be seen here in the left side of the picture, we have the schematic of the circuit that's going to drive the valve that's going to let the flow go through the microfluidic system. This is the actual PCB board that we designed for it to implement in the design, and this is the actual circuit. Here we can see the H-bridge circuit that we designed to drive this pump that is over here. This was the first alternative, but then we jumped to a second choice, which is the L298 pin, which contains all these transistors in only one chip, which is a lot more practical than the other implementation. This is the experimental setup that we've been using to do our electrochemical measurements. This is the BeagleBone, which controls the LMP91,000, which is the one in charge of doing the sensing. And these are the sensing platforms, and this is the chamber where the sensor is. This is one of the graphs that we have obtained with utilizing our system and validated with the other potentials that we have in the lab.